Alright, this is Chapter 9, Lesson 7. I'll be doing the guided practice out of page 778. This lesson is on independent and dependent events. Independent events means if you are doing two things, for example on this first one, they're flipping a coin and then they're rolling a number cube or a die. And so these two things would not affect it. It wouldn't matter whether you got a heads or tails. It would not affect the roll of the die. They're two separate events. Those two things are called independent of each other. Now, if what I did on the first thing affected or changed the probability of the second thing, that would be called dependent events. That'll be like number 3. When we get down to number 3, I'll show you that. All right, so the probability I flip a coin and get a tails, well, there's one way to get a tails out of two possible outcomes, so my probability would be 1 out of 2. My probability of getting a 3 on a number cube, well, there's a 1, 2, 3, 4, 5, 6, so there are 6 possibilities, only one of which is a 3. If I have to do this and this to get it right, if I have to do two things, it becomes more difficult, so I have to multiply these. I have a 1 out of 12 chance of getting that done. Probability of the first times the probability of the second gets me the probability that both of them will happen. So let's go to the second one. Probability, once again, I'm flipping a coin and I'm rolling a number cube. Probability to get a heads, well, there's one way to get a heads out of two possible outcomes. And then, that means I have to do both of them, so I'm going to multiply these things. Did I get an odd? Well, can't I get an odd by rolling a 2, a 4, or a 6? So I have 3 ways to win out of 6 total. I'll show you all those. 1, 2, 3, 4, 5, and 6. So if I simplify that, 3 out of 6 is 1 out of 2. So I have a 1/2 times a 1/2 chance. That gets me a 1/4 compound probability. So, number 3 is now going to be what we call a dependent event here. Because what happens is if we have cards labeled 5, 6, 7, 8, and 9, card is drawn and not replaced. That means when I don't replace it, it's going to change the probability of what's happening. And so the first thing has to happen, and the second thing has to happen, but it changes the probability of the second one. So, let's see, what's the probability that we draw 2 evens? Well, the probability I get an even, I have 2 possible ways out of 1, 2, 3, 4, 5. So the probability of getting even is 2 out of 5. But to get that right, one of those evens is going to be gone. It might be the 6, it might be the 8. So that changes the probability of the second one. The second time I only have 1 possible winner, not out of 5 anymore because I didn't replace it, 1 out of 4. So now I have a probability of 2 over 5 times 1 over 4. Once again, both of them have to happen, so I multiply. I can cross simplify here. 2 goes in there twice, 2 goes in there once. And I end up with a 1/10 chance that both things will happen. A 1/10 chance that both will happen. Do you see how that the first draw changes the probability of the second one? That's what we call a dependent event. A dependent rather than independent, where it has no impact or no effect on what the other event is. Probability of the second event.